Alright, in 6.2 we're going to multiply radicals and rationalize denominators. So two important things we need to remember. If we have the in root of a divided by b, that can be split up into the in root of a over the in root of b. So we just split those up into two. Well, if we have them being multiplied together separately, that's the same thing as us taking it and we can join them together underneath the radical sign. So we're going to assume that all variables represent non-negative values. And in our first example we have the square root of 8y to the 5th times the square root of 40y squared. So off to the side, we can take our 8 and make our factor tree. Well, 8 can be split up into 4 and 2, and 4 can be split up into 2 and 2. So we have 3 2's. So our 8, we can rewrite that as 2 to the 3rd, because there's 3 of them. And we still have times y to the 5th times, if we want to simplify the 40 can be split up into 5 and 8, and we just said 8 can be written as 2 to the 3rd. So we have 5 times 2 to the 3rd times y squared. So up top, we see that if we have them separated, we can combine them underneath the same radical sign. So let's go ahead and do that. So we can have the square root of 2 to the 3rd times y to the 5th times 5 times 2 to the 3rd times y squared. So we just took it all and combined it under one square root sign. So let's simplify that a little bit. If we take 2 to the 3rd times 2 to the 3rd, like we did in the very first section of chapter 6, when we multiply two numbers, we add our exponents. So if we take 3 plus 3, that's going to give us 2 to the 6th. And 5's by itself, so we have times 5. Times, if we take y to the 5th times y squared, we add our exponents to get y to the 7th. Because 5 plus 2 is 7. Alright, our index of this, like we talked about in 6.1, our index is the number out in front. Well, if we have the square root, the index is 2. So if we have 2 to the 6th, if our index is 2, we can get 3 groups of 2 to go into 6. So we have 2. If we get 3 groups, it's going to be 2 to the 3rd. And 5 is just to the power of 1, so we can't get any groups of 2 in there. So 5 stays on the inside. We have y to the 7th. Well, our index is 2. We can get 3 groups of 2 to go into 7. So y to the 3rd. And if we get 3 groups of 2, that's 6. So we're left over with 1y. So if we simplify that even more, 2 cubed is 8. And we're going to leave y to the 3rd times the square root of 5y. Let's do another one. Alright, so we have 3 times the cube root of 5x cubed times 2 times the cube root of 50y to the 4th. Alright, so we can go ahead and take our numbers out in front and multiply those. So we can have 3 times 2, and we still have times the cube root of 5x cubed times the cube root of 50y to the 4th. So all we did from here to here was move our numbers out in front that we're going to multiply together. So if we multiply those, 3 times 2 is going to give us 6. So we have 6 out in front. And let's go ahead and combine those. If we're multiplying 2 separated, we can combine them underneath the same radical sign. So we're going to have the cube root of 5 times x to the 3rd times, if we deal with 50 off to the side, make our little factor tree, that's 10 and 5, and 10 can be split up into 5 and 2. So 50 can be rewritten as, we have 1, 2, so times 2, times we have 2 5s, so 5 squared, times y to the 4th. So we just took our 50 and split it up into 2 times 5 squared. Alright. So now we can go ahead and simplify a little bit on the inside. So we still have 6 times the cube root. Well, we have 5 times 5 squared. We add our exponents, so this is 5 to the 1. And our exponent here is 2, so it would be 5 cubed. Times, well, we have x by itself, so it's going to stay x to the 3rd. And we have 2 by itself, so times 2 times y to the 4th. Alright, so we still have 6 on the outside. So our index here is 3. So let's deal with our 5 cubed first. Well, if our index is 3 and our exponent is 3, we can get one group of 3 to go into 3. So we can take a 5 out. That's our one group that we're bringing out. So that's done with. So then we go on to our x cubed. If our index is 3 and we're looking at our exponent, which is 3, we can get one group of 3 to go into 3. So we can take an x out. This is just 2 to the 1st power. So we can't get any groups of 3 to go into 1. So 2 stays on the inside. If we're talking about y to the 4th, we can get one group of 3 to go into 4. So if we bring out a y, that's our one group. And 3 goes into 4 one time, and we're left over with 1. So we still have a y on the inside. And that's still the cube root. So if we simplify that, we have 6 times 5, which is 30. And we still have x times y, so xy. And the cube root of 2 times y is just 2y. Alright, our next example. We have the square root of 500 over the square root of 5. Well, up top, we can see that if they're separated, it's going to be equal to the same thing as if we bring them together underneath the same radical. So these are separated, so we can rewrite that as 500 divided by 5 underneath the same square root. So square root of 500 divided by square root of 5 can be rewritten as a square root of 500 divided by 5. Well, 500 divided by 5 is 100, and the square root of 100 is 10. So that one was fairly easy. Let's do one more on this page. Alright, so we have the square root of 20ab divided by the square root of 45a squared b to the 3rd. So just like this one, they're separated, but you can rewrite them all under the same square root sign. So instead of 2, we're going to have 20ab divided by 45a squared b cubed. So let's kind of simplify that a little bit. So if we want to rewrite 20, if we do our little factor tree off to the side, that's 10 and 2, and 10 is 5 and 2. So we have the square root of, instead of 20, we have 2, and we have 2 2, so it's going to be 2 squared, times 5, and there's only one 5, so times 5, times a times b. Alright, let's simplify our 45 a little bit. 45 is 9 and 5, and 9 is 3 and 3. So instead of 45, we can have 3, and there's 2 of them, so we're going to have 3 squared, times, we have 1 5, times a squared times b to the third. Alright, so 5 over 5. 5 divided by 5 is 1. So those cancel each other out. So we have 2 squared. We have a divided by a squared. When we divide, we subtract our exponents. This is a to the 1. Well, I'm going to start with the 2 on the denominator so it stays positive. When you start with the denominator, your answer stays on the denominator. So if I take a squared minus a to the first, that's going to leave us with a to the first. And since I started on the denominator, my answer is going to be on the denominator. And we still have 3 squared on the bottom. So 3 squared times a. Now we have b to the first divided by b to the third. Well, I'm going to start with the denominator, so my answer is going to be on the denominator. Well, b to the third, our exponent is 3. b to the first, our exponent is 1. So 3 minus 1 is b squared. So we just simplified a little bit. So if we think about this, this is the same thing as taking the square root of 2 squared divided by the square root of 3 squared times a times b squared. Remember, if they're under the same square root, that's the same thing as taking the square root of the top divided by the square root of the bottom. So, the square root of 2 squared, our index here is 2. We can get one group of 2 to go into 2, so we can take a 2 out. Divided by 3 squared, our index is 2. One group of 2 can go into 2, so we're left with a 3. And if you remember, a square root when the index is 2 undoes the squared, so you're left with 3. Well, our exponent of a is just 1. There's no groups of 2 that can go into 1, so our a is going to stay underneath our radical. We have b squared. Well, one group of 2 can go into 2, so we can take out a b. Okay, so on the next page we're going to talk about rationalizing the denominator, but right here we need to rationalize the denominator. We do not want that square root on the denominator for our answer. So in order to rationalize the denominator, we're going to take it times that square root. And when you take it times the square root, you have to take the top and the bottom by the square root. So we're going to multiply by the square root of a over the square root of a. So if we were to do that, 2 times radical a is just going to be 2 square root of a over the square root of a times the square root of a is just a. So it's just what's on the inside of that. So we're left with 3b times a. So on the next page, let's talk about rationalizing the denominator. So rationalize the denominator. So we want no radicals in the denominator, like in our last example. And we want no denominators in the radicals. Meaning, so the first one, we want no radicals in our denominator. So meaning if we have the square root of x over the square root of 5, we have radical 5 in our denominator. We don't want that. The bottom piece right here where it says no denominators in the radicals. So if you have radical x divided by 5, underneath that radical we have a denominator. We don't want that. So let's do a few examples where we work with that. Our first one, we have the square root of x over the square root of 5. So right now we have a radical in the denominator. So we need to rationalize it. In order to do that, we're going to take the numerator and the denominator times the radical that's in the denominator. So we're going to take the numerator times radical 5 over the denominator times radical 5. So we have the square root. We can multiply what's inside our radicals. 5 times x is just 5x. So we have the square root of 5x. If you take radical 5 times radical 5, you're left with what's inside since they're both 5. Radical 5 times radical 5 is 5. Let's do another. So we have the cube root of x over the cube root of 5. So this one's a little bit different because our index here is 3. So in order to rationalize the denominator, we have a radical in the denominator in which we don't want. So we're going to have to take both the numerator and the denominator by the cube root of something. Well, if our index is 3, that means we're going to want 3 5s. So we're going to want 5 to the third power in order for them to cancel out. So if we have 1 5 here, we're going to have 5 squared here. So if you multiplied those, that would be 5 to the third. Since our index is 3, that's what we need. So whatever you do the denominator, you have to do the numerator. So if we do that, we're going to have the cube root of, we can take 5 squared times x, which is just 5 squared x, over the cube root of 5 times 5 squared, which is going to be 5 to the third, which is going to turn out to be the cube root of 5 squared is 25 times x is just 25x, over our index is 3, our exponent is 3. You can get one group of 3 to go into 3, so we're left with 5, with no left over. Our next one, we have the square root of 5x to the 4th y over the square root of 2x squared y to the 3rd. So we have a radical divided by a radical. That's the same thing as taking both of those divided by each other inside the same radical sign. So we can take the numerator, which is 5x to the 4th y, divided by 2x squared y to the 3rd. So instead of having a radical divided by a radical, we took the whole thing divided by each other underneath that same radical sign. So if we simplify what's inside of there a little bit, we're going to have the square root. 5 divided by 2 can't be simplified, so we still have 5 over 2. We have x to the 4th divided by x squared. When we divide, we subtract our exponents, so we have 4 minus 2, which is going to be x squared. And I started with the 4, which is in my numerator, so my answer stays in my numerator. We have y divided by y to the 3rd. Well, I'm going to start with the denominator, so my answer is going to be in the denominator. My exponent here is 1, so 3 minus 1 is 2, so we're going to have y squared. Alright, so since our index here is 2, we want our denominators both to be squared. Both have an exponent of 2. Well, our y already has an exponent of 2. So we just need this 2 to be squared to undo that square root. So in order to rationalize it, we're going to take both pieces times the square root of 2. Because 2 times 2 is going to be 2 squared. So if we do that, I'm going to split them up again, because we know they're the same thing. Underneath our radical sign, we have 5 times 2 times x squared. And that's over the square root of 2 times 2 is 2 squared, and we still have y squared. So that's going to equal 5 times 2 is 10, so we have the square root of 10. The square root of x squared is x. So we can go ahead and take that out. So our index is 2. One group of 2 can go into 2. Divided by the square root of 2 squared is 2. And the square root of y squared is y. So now we don't have a radical in our denominator, so we're good to go. Alright, so let's do one more. We have the cube root of 10ab cubed c squared divided by the cube root of 18a cubed b times c. So looking at our top piece, let's break 10 up. Well, 10 can be broken up into 2 and 5. And if we look at the bottom, 18 can be broken up into 3 and 6, which can be broken up into 3 and 2. So if we were to rewrite that, we know if we have a radical divided by a radical, that's the same thing as putting it all underneath the same radical. So we have the cube root, and we can only do that because the index are both 3 on both of them. So they're the same, so we can combine them. So 10, we said it can be broken up into 2 times 5. So we have 2 times 5 times a times b cubed times c squared divided by 18. We have 2 times, we have 3 and 3. Well, 3 times 3 is 3 squared, so we have 3 squared times a cubed times b times c. Alright, so 2 divided by 2 is 1, so they're going to cancel. So we have the cube root of, we still have 5 up here. And I'm going to break them up again. We have the cube root on the bottom as well. So since 5 and 3 didn't cancel each other out, we have 3 squared on the bottom still. Alright, so we have a divided by a cubed. Well, this is a to the first. When we divide, we subtract our exponents. Since 3 is bigger, I'm going to start on the denominator, so my answer is going to go in the denominator. Well, 3 minus 1 is 2, so we end up with a squared in the denominator. We have b to the third divided by b. Well, 3 is bigger, which is in the numerator, so that's where I'm going to start, which is where my answer is going to end up. So 3 minus 1 is 2, so we're going to have b squared. We have c squared divided by c. I'm starting in the numerator, so my answer is going to be in the numerator. 2 minus 1 is 1, so we're left with times c. Alright, so in order to rationalize this denominator, we have a radical down here, and we don't want that. So we're going to take the numerator times the cube root of something over the denominator times the cube root of something. Well, we want 3 to the third since our index is 3, but we only have 3 squared. So 3 squared times what gives you 3 to the third? Well, 3 squared times 3 gives you 3 to the third. Times, since our index is 3, we want a squared to be to the third power, not 2. So a squared times a gives you a to the third power. Whatever you multiply the denominator by, you have to do the same to the top. So if we do that, we're going to have the cube root of 5 times 3 is 15 times a times b squared times c. So I'm just combining this whole top piece. So a b squared c over 3 squared times 3 is 3 cubed. Well, the cubed root of 3 cubed is 3. A squared times a is a cubed. The cube root of a cubed is a. So now our radical in the denominator is gone.